Hello everyone, I'm going to talk about coupled circuit in electrical devices and its main application. Myself, Tan K. from Tyagaraja College of Engineering, Madurai. Okay, let's start. What is mean by coupled circuit? Coupled means joined. When two circuits are joined together to transfer energy is called coupled. Inductor plays the major role in voltage regulation. Coupled circuit not only contains inductor but also capacitors and resistors are being connected with the circuit. So coupled circuit refers into two different circuits joined together to transfer energy from one circuit to another when one of the circuit is energized. Coupled circuit has been classified into two categories. 1. Electrical coupled circuit. 2. Magnetic coupled circuit. Electrical coupled circuit. The circuits has been physically connected through wires. Example, you can see this figure. The source, capacitor, inductor and the resistor are all being connected through wires. Magnetic coupled circuits are nothing but the two inductors are not being connected physically, but due to magnetic flux change, the two inductors are being connected. Like if I say when the source is applied, the current will pass through the inductor L1, which produces flux and which will affect the inductor, second inductor, which may produce an opposition EMF which flows in the opposite direction. This is called magnetic coupled circuit. Next, dot rule or dot convenient. Dot rule, it is a technique used to find the voltage polarity in the circuit. Using KVL may not be convenient, but dot rule is much more easier way. Dot rule are of two conditions. When current enters at the dotted terminal of one coil, then it induces a voltage at another coil, which is having positive polarity at the dotted terminal. Induced voltage is in mutual inductance. If the current leaves from the dotted terminal of one coil, then it induces a negative polarity of mutual inductance at the other coil dotted terminal. You can see in this images or the current entering in the dot and leaving the dot represents the voltage polarity. Electrical coupled circuits, as I said, these circuits are physically connected between the two coils. Couplings are decided by four types: series aiding, series opposition, parallel aiding, and parallel opposition. As we see in the resistors, series, parallel, all are same here. In series aiding, the two inductors are connected in series, aiding the presence when the current enters the dotted in both the inductor is called a series aiding. Here, the equivalent induction is nothing but L1 plus L2 plus L2M. Here, 2M represents the mutual inductance between these two inductor. If the dots are of in the opposite, like here the inductor L1 current is entering through the dot. If the current is leaving the dot of inductor L2, it is called series opposition. In this, the mutual induction will have negative sign, and the equivalent induction is nothing but L1 plus L2 minus 2M, because only the mutual inductance has the opposite polarity. Now, the parallel of aiding is also same. When the current enters into the dot of both inductor which is connected in parallel is called as parallel aiding. Here, the equivalent is L1 L2 minus M square by L1 plus L2 minus 2M. Parallel opposition is nothing but when two inductors are connected parallel, in which one the current is entering into the dot and other in the other inductor the current is leaving. This is called parallel opposition. The equivalent inductor is nothing but equivalent equal to L1 L2 minus m the whole square m the square divided by L1 plus L2 plus 2m. Magnetic coupled circuit. Here there will be no physical contact between the two conductors, but it has also two types, aiding and opposition. Here in this diagram you can see the current is entering into the dot, where in the other inductor current is entering into the dot. This is called aiding. Opposition is that now you can see the opposition is that when one of the inductor the dot is entering and the other inductor the current is leaving. This is called opposition. Here the V1 represents the inductor in which the current is changing per unit time, and the magnetic flux induced in the second inductor due to mutual inductance, because here the mutual inductance is inducing a current I2 per change for change in time. V2 also can be determined by the same way as V1. Applications. Induction motor, where we can find mostly used in nowadays for generators, etc. Second application is transformer. Without transformer we cannot live today. Every area has a transformer. Each village has more than 3 to 4 transformers. Transformers are the main application of separating electrical charge to the particular areas. Third application is inductive sensors. Sensors are nowadays more widely used. Even a blind man can use sensor to visible the things in front of him. Fourth is to prevent the overflow of current to the load. When a charge is flown from a higher source that may affect the other load which can only bear low voltage, in that transformers like magnetic induction will protect the load, will protect the circuit from the high current. Fifth, it is very cheap and less maintenance unit, and we are going to see one of the application, transformer. As I told, transformer became the more important in electricity separation. It is a passive electrical device and a static device. Passive represents it does not produce any energy but helps in the flow of energy. Static device represents that it does not move its position to transfer energy. As you see in DC motors, the coil rotates to produce electricity or transfer energy. In this, the energy transfer takes place through varying current in one coil, which produces a varying magnetic field in the other coil of the transformer without any change in the frequency. It works under the principle of electromagnetic induction. This transformer has two coils, primary coil, secondary coil. These two are connected through transformer core, which may be a silicon based metal. There are two types of transformers. One is step up transformer and the second one is step down transformer. Step up and step down transformer are being classified through the number of turns in the primary and the secondary coil. When the primary coil has low number of turns than the secondary coil, it is step up transformer. When the primary coil is having more number of turns than compared to the secondary coil, it is called step down transformer. There is been a ratio relationship that for the voltage, number of turns and the current, which is more useful to find the energy output and the energy loss during this process. Here, number of turns is for primary coil N1 and the secondary coil is N2. And the turn ratio is A equal to N1 by N2. And the voltage equal to number of turn ratio equal to V1 by V2. Current turn ratio equal to I2 by I1. As I did a mistake here, current will be indirectly proportional due to when number of turns increases, the resistance increases, due to which the current decreases. So here the current ratio will be I2 by I1. Okay, these are the things you can see in uses. Here transformer is to isolate the low voltage circuit from the high voltage circuit in case of substations, control circuitry circuits in industries, etc. They are also used in impedance matching. Like if you see this diagram, when if you speak in a mic, the amplifier amplifies your voice and gives to the transformer, which helps to increase the tune your voltage according you turn the mic off and on. Here the second diagram represents the transformer of every village. You can see in your own village also. Thank you.